those. So we'll go now into the kind of the panel discussion bit. I've got a couple of questions, I guess, to kick us off, and then I'm sure there will be people. So if people want to ask a question, then obviously feel free to raise your hands. And one good thing about Teams now is it tells you what order people put their hands up, so there is some equity in that process. But equally, if you don't have access to a microphone or can't turn it on, then add questions to the chat or to the Padlet again. One of my questions comes from I've run my own space systems module a couple of weeks ago, and we had a quite heated discussion around sustainability of the space environment, mostly. So I just really want to get kind of the panel's feeling on when you're kind of balancing the ability of companies to make money versus doing the right thing, and also the length it takes to get any international agreements. So if we're talking about international cooperation to reduce the space debris problem, and I guess the current kind of entrenchment back to national interests, do you think there is any hope? I know Stuart several times says, yes, there's hope here. But overall, do you think we're going to solve the problem quick enough to prevent a catastrophic breakdown of our ability to use space?
I think you can argue that some of the companies are starting to recognize the sort of reputational risk of, polluting the light sky. So, Starlink did spend some time trying to reduce the reflectivity of their satellites to the point where, unless you're in a very dark sky site, you're probably not going to see stuff with the naked eye. But that doesn't really solve the problem from the professional astronomer's point of view. The Starlink constellation satellites are still going to create streaks across the images taken by professional telescopes, and it's a slightly unfortunate situation that historically some of the astronomers were very keen to see the other side of the universe, so they developed very large telescopes with very narrow fields of view, and the chance that you got a satellite in your field of view were quite low. But recently we've seen with things like sort of asteroid searches and the interest in exoplanets, the astronomical community is actually moving towards telescopes with much wider fields of view, and so almost inevitably we're on a collision course with the mega constellations, because you're almost certainly going to get satellites flying through most of the images that things like the Rubin telescope collect. So it's a tricky problem.
Okay, does anyone else want to come in on their thoughts on that one?
Rosie, do you want to dive in? If not, I'll dive in with a comment.
Go ahead, Mike.
I don't think space is unique in this problem. An economist would call it the tragedy of the commons, where a person or a company will act in their own vested self-interest and disregard the impact of their activity on others. And we've seen it many times through the course of humanity. So for me, hey, we've been here before and we managed to resolve it terrestrially. So I share Stuart's enthusiasm. I'm sure we will resolve it. And I guess as an entrepreneur, I'm pathologically optimistic anyway, and therefore I see huge opportunities here. As we're seeing with Astroscale, hey, if there's a problem, hey, I don't need to build satellites and perhaps contribute to the problem. Maybe there's a killer business model in here of how you're about cleaning up this challenge. So I think that there's huge opportunities for tech entrepreneurs while we wait for the legal environment to catch up and companies to act in what I think is actually should be a vested self-interest in actually keeping space as clean as we possibly can. Because if we want more satellites on orbit, in the same way, if we want more fish in the sea, we've actually got to reduce our level of pollution and start looking after the wonderful asset that is low Earth orbits and further afield. So yes, I am optimistic, and we'll get there.
Okay, thanks. Did you want to add anything, Rosie?
Yeah, I mean, the European Space Agency recently funded ClearSpace, and I think it was like 50 million euros or something like that. So there is funding going towards projects like this. So I feel like, yeah, there's hope. I believe there's hope.
Yeah, I think as Mike said, you have to be optimistic, particularly if you're an entrepreneur. So perceptions of risk may be different. So another question from me, and then I will hand over to other people. And I guess this probably is directed at Mike first. So you were talking about obviously the use of AI, onboard AI, to understand a satellite's local environment and perhaps make movements to avoid any potential conjunctions. And I think, I can't remember, I may have heard this somewhere else, but there was this idea that if you took something like the Skylink constellation, which has thousands of satellites in, and they all had this behavior, then you could start to see something the equivalent of a murmuration of starlings. And if other satellites don't have that technology, you're actually increasing the risk. You may be trying to protect your own constellation, but does that then increase the risk? And is it a bit like autonomous driving? Until all cars are autonomous, there's always going to be accidents.
Yeah, that's a great question. What you're talking about is unexpected, or so-called emergent behavior from complex systems. One of my favorite examples of AI going completely awry was a spider robot that wasn't taught how to walk like a spider, and the job of the AI was to maximize the efficiency of the spider when it is running. And the AI worked out that the way to do that was to minimize the number of limbs in the ground, in contact with the ground when it was running, but it managed to flip itself over. And now its new orientation was on its back, and it was actually its elbows touching the ground, and it evolved a completely new gait, never seen before. And it was actually more efficient than if it was the right way up. So we do get some really interesting emergent behaviors from complex AI systems. But of course, you know, forewarned is forearmed. If we know one of the downsides could be a swarm-like behavior, then we inherently program into an AI system that it can't move to that type of swarm behavior. So we set the boundaries in which it has to optimize itself within. And of course, it's going to be like the early days of autopilot. You know, the flying community and pilots were incredibly skeptical of allowing a machine to essentially fly an aircraft. So the industry went through a long learning curve while it became comfortable with autopilots. And now where are we today? All of us probably would actually prefer, if it was the autopilot, flying an aircraft, and we allow an automated system to control essentially the lives of hundreds of people. So on orbit, I think we're going to go through the same learning curve. We're going to be incredibly skeptical. We're going to be very nervous about what technology can do. So we'll set the boundary conditions. We're not instantly going to move to a fully autonomous mega constellation. We're going to pick parts of the constellation. We'll give it a chance to be semi-autonomous and report what it's going to do back to ground control before it's allowed to carry out that behavior. So we'll have these checks and balances, and the more we understand and the more we trust the systems, the more we can then hand over and let what machine intelligence does way better than humans, which is actually look after machinery way better than a temperamental and emotional human would do.
Okay, I would say I would trust autopilot, but perhaps not when you're on a Boeing 737 MAX.
So will always be the challenge of new technology going awry. Yeah.
Stuart, did you want to?
I'd just comment on a couple of the things that Mike said there, actually. He was talking about a sort of concept of operations that involves, you know, passing some of the surveillance data, you know, down to the ground, and the latency of that communications and the availability of in-satellite links, I think, will be an important part of being able to do that sort of thing in a timely fashion. And I mention the time element because it's worth remembering that, you know, if you're unless you want to fly a really big camera, the sort of images that Mike was showing of resolved satellites, you don't start to get to, you know, a resolved image of the thing that's flying towards you until maybe it's somewhere around 50 kilometers away, and at the speed that things travel in low Earth orbit, that's less than 10 seconds away. So, you know, the ideal situation is you're able to recognize a problem a long time in advance and make a graceful maneuver out of the way using relatively little propellant. Unfortunately, because everything's traveling very fast, that's quite hard to do. So I think, I wish Mike every success, and I just hope that we can sort of extend the ranges and the accuracy of the predictions, the sort of stuff that Chris Bridges was talking about earlier, because it'll really help us do the sort of more graceful, elegant thing, so that, the whole point about a murmuration of starlings is the starlings very rarely bump into each other. So actually, if we could emulate that, it might actually be quite good,
Stuart, perhaps I could just dive in very quickly on a point you made. One of the very powerful things, but perhaps lesser known aspects of a certain type of AI is its ability to work with much, much lower resolution of data than a human would. And you're absolutely right. For a human to be able to take action on a visual image captured on orbit, you're going to need a pretty impressive camera system. AI, in terms of processing its data, actually downscales images anyway in order to speed up the processing. So there is a way and techniques of absolutely optimizing AI to get away with a shockingly few number of pixels and still make very accurate decisions. And that's a very active area of research in machine vision systems. But I take your point. It's certainly a non-trivial problem. There's going to be some interesting scenarios that will need to be worked through. But as ever, I am that pathological optimist.
Right, it does sound like another cause for optimism. I was going to make that gag, but you got there before me, Mike.
Exactly. Yeah. History is full of naysayers saying technology doesn't work, so I'm eternally optimistic.
Right. I don't know if this is a topic for you, Rosie, but jump in if you would like to.
AI is not my strong point.
Okay, that's fine. So I will. Peter has been very patiently sitting with his hand up. So, Pete, I'll hand over to you for your question.
So first of all, before I ask this question, I just want to say I have a massive love for rockets, okay, and I really want to see a UK rocket company do well. But in this forum of sustainability, okay, we've talked about how Skyrora was very good at using new fuels and an upper stage which can be reused. But does Skyrora have any mitigations for the first stage, second stage of its launcher? Because as you said, 16 launches a year is going to be plopping a lot of stuff into the oceans. Are Skyrora exploring any technologies to try and recover these stages in a manageable way? And sort of more of a wider question, which maybe the panel can all answer on, is how does one, how are you going to manage the expectations of the population who are very used to seeing SpaceX recover their vehicles back on the launch pads or whatever? I know technologically it's difficult, and there's good business reasons to do so a different way. But how do you manage the public to keep them on board?
Yeah, so my first point would be, in general, with launch licenses, we have to promise that we will at least recover the boosters from the ocean. So a lot of rocket companies actually just leave their boosters and let them sink to the bottom of the ocean, but we will be recovering them. In terms of reusing the boosters, our initial plan was with our demonstrator launch of the XL rocket, we would just wait for it to splash down, possibly with a parachute to slow down the descent, and see if we could reuse the booster just from the sea. I mean, our engines use a very strong super alloy called Inconel, and we're hoping that that'll be resistant to the corrosion of the sea salt in the sea. If not, then we'll probably look at other options. But I think what you have to remember is with the Falcon 9s, those rockets are a lot bigger than our rocket's going to be. And to make it economically viable to reuse the booster in the same way as they're doing, it's probably not possible. So we'll have to come up with a new solution, maybe similar to what Rocket Lab is doing. I don't know if you saw where they let their booster fall down with a parachute and then they tried to catch it with a helicopter. I think we would have to go for a solution similar to that. But right now, we haven't specifically got a solution ready just yet.
Great, thank you very much.
Is that everything? Can I just make a follow-on comment?
Yes, please. Yeah,
Rosie. Sorry, Rosie. Please, let's have a conversation because I've got a PhD student working on a steerable parachute and cool. Parachute. just for this exact problem. So anyway.
Thanks, Pete. So I think Chiara was next in the list, or the second person with their hand up.
Hiya, thanks very much. And thanks for the talks today. It's been really, really interesting. I was just going to ask, we heard from some of the talks earlier, the idea that the students that we're teaching at the moment, you know, in 2050, they're going to be the engineers leading these companies and really taking on these challenges. So I'd love to hear from each of you, from your perspective, what are the skills that you would love to see in the graduates coming out of university today, you know, for you to be hiring them today and to tackle these challenges, but also maybe thinking about that challenge of 30 years in the future. How should we be training our graduates to make sure that they can take on these challenges and lead us into this sustainable future?
Would you like to go first, Mike?
Yeah, certainly. Yes, a great question. And in terms of people that I've hired in previous businesses, such as Oxford Space Systems, kind of what have I looked for in recent graduates? I would say it boils down to an inquisitive mind for me, because when you look at a graduate's qualifications, with no disrespect to a recent graduate, but on paper, you can all almost look like carbon copies of each other. You know, you've all gone through the education system, you've all got your great master's degree in aerospace engineering, whatever it is, and your only point of differentiation is kind of really your final year project. So that's really hard to decide on paper who you actually want to bring in for interview. So I've always looked for someone who's gone beyond what's just on paper. And if you really want to get into, say, space engineering, what engineering have you done on the side? You know, show me this is something that you're genuinely passionate about. So I hired a guy at Oxford Space Systems who completely rebuilt his own car engine and was working on his own electric car. So that clearly shows a real passion for engineering. And the inquisitive mind that I touched on, you know, show that you've got a real genuine interest in engineering way beyond what you've just studied. So come and be able to talk about some of the engineering advances going on in the world, why you find them fascinating, how you think you might improve on those things. And then finally, I think because certainly space, and I think technology in general, is becoming so specialized, so niche, you are going to have to work across disciplines with people to unlock the full potential of technology. Therefore, great interpersonal skills, showing that you can work as part of a team, that you're genuinely curious why people would hold perhaps a position that's different from yours. As an engineer, you will constantly be challenged on your designs, constantly challenged on the way that you think. So be open to being challenged and approach with curiosity other people's ideas. So I think that's quite a long waffly way to say it's more about being a rounded package rather than just being the best that you possibly can in that technology. It's more than just being smart technically.
Yeah, I think I would endorse Mike's comment. I mean, my PhD was in constellation design, so looking at you know, how to optimize orbits for different you know, types of application, and that's quite a long way from the sort of stuff that say Chris Bridges was showing us earlier, where he showed us, you know, some of the innards of the electric systems that he was designing for you know, providing tracking of spacecraft. And you know, there's quite a long, you know, span of skill sets between those two things. And the more of that, you know, sort of spread that you manage to, you know, sort of master, the more useful you're going to be in the community, I think. I mean, I'm going to confess that, you know, my electrical engineering is virtually non-existent, but hopefully I can, you know, sort of contribute some ideas about orbits and make myself useful. But you know, people that can spread themselves across that wide range, and I've met a few in my career, I think have been the people that have most impressed me.
Yeah, also I feel like from a different perspective, I'm actually a recent graduate and I've been in this role for just less than a year, and my degree was in geology with planetary science. So, I mean, I don't really necessarily have business experience, but what I do have is a very clear 4-year degree filled with passion for space. So I definitely agree that passion is something that will really like impress companies, especially our company. And on the business team, I mean, we hire people from a range of different backgrounds and degrees. So again, it's just your motivation that will like mostly impress us, I would say.
Just building on what Rosie said, yeah, I think being passionate, you've got to do something in life that you really enjoy. All the engineers that I've been fortunate enough to work with, genuinely live and breathe and believe in what they want to do. They don't watch the clock. It's 5 o'clock. They don't go home at 5 o'clock. We've got a killer problem to solve. We want this technology, on orbit in a year's time. So make sure you really, really enjoy what you're doing, especially if you have entrepreneurial aspirations, because if you do start your own business, you will live and breathe it, and there's no such thing as a holiday. You just go and think about the business in a different place. There's someone pointed out to me, and I've since learned that if you do become a tech entrepreneur and you take external investment, that's tougher to get out of than a marriage. It's easier to get divorced than separate from your investors. So really make sure you're absolutely passionate about your technology.
Great, thanks. Chris, you've turned your camera on. Is that because you want to jump in with a question?
I feel Mike's sentiment definitely about the entrepreneurship, but clocking off at 5 o'clock is a good thing. And it was just a comment to, especially for our academic colleagues as well that have very similar mindsets. In that we don't switch off from that stuff. It's I think those things as well, like resilience as well, are good things for the future. And knowing when to stop yourself and when to say no. So those are all useful skills too. Didn't mean to, tread on anyone's parade.
Thanks, Chris. There are no more hands up, but I've got another question. So if that's okay, So at the recent summit, we had the science minister talking about the kind of UK objectives in this area, and we've kind of talked about some of those, which is great. So we've kind of talked about regulation, we've talked about working internationally, and we've talked about active debris removal. And the fourth strand that he was talking about is developing simple metrics to measure sustainability. Any thoughts on what those simple metrics could or should be?
Well, if we can get a decent handle on the population, i.e. measure all the things that are relevant from the point of view of killing satellites. So that unfortunately does mean trying to get a handle on all the stuff down to about 1 centimetre. There is then the sort of challenge to try and reduce the error ellipsoids. I mean, Chris was talking about, good measurements and bad measurements. At the moment, we have quite a lot of objects with very large error ellipsoids around them, covariances. We need to do precision space surveillance with the idea of then being able to take advantage of the same sort of concept that has happened in the air traffic control domain. So as aircraft have got better at navigating, they've been able to reduce the time between the landing slots at major airports, because basically everything is tracked to higher precision, so you can operate safely with smaller gaps in between. And there are people in the space community sort of suggesting that we could do the same, and I think that's true. So carrying capacity and the sort of how much we can get out of space does depend to at least some degree on how well we manage the stuff that's up there and track it.
Okay. Rosie, do you want to jump in?
Again, I don't think this is one for my background.
Okay.
Unless you want to talk about meteorites, then why not?
Fair enough. So, Mike.
I think Stuart summed it up brilliantly. It starts with let's measure what we've got, then more accurately quantify what's on orbit. But then I think moving forwards as well, just to add and build on what was said, making sure the technologies we use actually reduce debris or mitigate as much as they can. So separation rings, historically we've been quite sloppy with some of those mechanisms. So designing designing technologies to be as clean as they possibly can, and of course, critically designing systems for ablation. You know, we want the stuff to be able to deorbit and burn up as quickly as we can. We want to get it out of orbit, but we don't want to be creating debris showers, you know, back on Earth. So I think more work on intelligently designing these for sustainability as well. But not survivability. Sustainability of space, but not survivability of re-entry.
Great. Yes, Alison now has a hand up, so please.
Thank you. I've actually got two questions. I was waiting because I was enjoying the conversation that you had before, but I've got one technical question to Stuart and one business-related one to Rosie. So I'll start with the technical one. In your recycling of the debris as fuel, I was interested that if you're going to use aluminium as a fuel propellant, aren't you going to cause the same problem that you're concerned about with the debris falling into the atmosphere? Because then you've got a spray of ions eventually finding their way into the atmosphere and reacting immediately with ozone to create aluminium oxides. Maybe that's going to take longer, but I think it's the same problem.
So the way that most spacecraft get around the potential problem of sort of charging themselves is that you have an electron gun associated with your electric propulsion system, so that you actually fire electrons into your exhaust to neutralize it as it leaves the spacecraft. And if you don't do that, you end up with a very highly charged, you know, sort of spacecraft, because you're ejecting one particular electrical species from it. So I think that, if I don't know the details of the Newman space technology, but if it works like existing electric propulsion systems, the idea is to try and neutralize the exhaust from the spacecraft as it exits the spacecraft by firing electrons into the beam. So I hope that wouldn't necessarily be a problem.
In that case, those ions become single atoms,
I
then
believe.
perhaps, but still they would be able to react in the atmosphere when they finally got there.
Yes, I think that's probably true. I think it's a point that somebody that understands the sort of the physics of the upper atmosphere would be better placed to assess than I, about whether it's better to have stuff coming down in lumps rather than be distributed more like a mist, if you like. I don't know the answer to that particular question, and it's only relatively recently that people have started, you know, sort of raising the concerns about the amount of stuff that we might, you know, be dumping into the atmosphere. And I think they're still, you know, working to convince people that actually, you know, it is actually a problem, in the sense that, you know, we've recognized that there's lots of meteoritic material coming in for ages, and the meteoritic flux is still, you know, on a factor of 30 greater than the satellite material that's coming down. But what they're arguing is that it matters what different elements are involved, and so I think we need to develop our understanding of exactly what happens. We've seen some evidence that I don't know whether Rosie, you know, is you know, because it's as a launch vehicle related issue. There are some launch vehicles that definitely create effects in the upper atmosphere that affect things like the propagation of GPS signals. They basically leave an ionization trail behind them, and you know, so there are other aspects of our space operations that can influence the atmosphere, and I think we're going to have to work harder to understand what the longer term effects are.
Thank you very much indeed. I think that sounds really a very important subject area. Thank you. Can I ask the second question, which is to Rosie?
Of course.
I was interested to hear that you're talking about Scotland being pretty much the entire supply chain, design and launch platform.
Mm-hmm.
Welsh government has been trying to get Wales activities in space going, and they similarly were pushing for a spaceport. You've got one in Shetland. Wales hasn't been quite so successful. What should Wales be learning from Scotland?
Yeah, that's a good question. I mean, I guess if it's a spaceport in Wales, it might only be horizontal launch capability, which kind of limits what kind of rocket launches you could do from there, if I'm right in assuming that. So for example, in any spaceports in like the north of Scotland, they do vertical rocket launches, which is where they just have a rocket like ours where it goes up vertically. But sort of in the south coast, and I would assume Wales as well, the position that the spaceports are, I reckon, would be there for horizontal launches, which are less popular. I think most of the companies in the UK are building rockets for vertical launches, so that might be an issue. And I don't think that's something you can just solve with money or anything. This is assuming that I'm right about the horizontal launch. Yeah, apart from that, I mean, I think the reason that we went for Saxavord is because of how far along they are in the process of getting permissions to build. So they already have permission to build the spaceport there, and so of course we're going to go for the one that's going to be ready first because we want to launch as soon as possible.
Okay, so from your point of view, it's the position of the spaceport that was actually the key thing.
I would say so, because I think in terms of horizontal launch companies, I think it's just Virgin Orbit in the UK, and they've chosen the spaceport in Cornwall. So yeah, but again, I need to check that. Someone correct me if I'm wrong.
Yes, okay, I'm interested generally because of the all different aspects. There's all the technology development. I think Scotland's got a stronger business. Well, the way that Scotland works is much centred around Glasgow and Edinburgh, and there's a huge amount of tech development going on in that area. Whereas in Wales, it's much more distributed, and I don't think there's quite much the same sort of centre activity. But the spaceport that was being pushed by Wales was in Llanbedr, and they were looking, to be honest, they were looking at horizontal launch because that was thought to be more efficient. But I think that was the one region where vertical would have been possible.
Okay,
so,
yeah, and also another point, I think Glasgow is the place in Europe that's manufacturing the most satellites. So that's probably another big reason why a lot of the companies have decided to manufacture rockets and launch from Scotland, just because that's where all the satellites are.
Oh, thank you. That's been really interesting. Thanks.
Great. Thanks very much. So yeah, there's no more hands up, and I don't think I've seen anything else on the Padlet particularly. But there have been lots of useful shares on the Padlet of various resources that people might want to look at afterwards. So I think we can wrap this part of the session up. So again, big thank you to our 3 industry speakers for giving us your time and covering some really interesting topics related to this subject. I think, yeah, I've learned some things. I'm sure most of us here will say we've learned something that we can perhaps take with us into our teaching as well. So obviously you're welcome to stay, but also recognise you have day jobs, so not expecting you to stay around for the remainder of the workshop if you have other things. But yeah, our huge thanks for spending the time with us.